Our world and beyond. Space, in partnership with the European Space Agency.
Because the sea is something from my childhood, and because we always dream of the sea. I mean, I've always dreamed of the sea, so how to show it if not by making a film? But the best way of watching the sea is to have this satellite view of the planet. That changes everything.
French filmmaker Jacques Perrin is gearing up for the release of his new film Oceans in the spring. The film took years of research and filming, but more than that, Jacques Perrin says he was also inspired by space scientists. ESA, the European Space Agency, helped to produce the film.
With ESA's satellites, there's another view of the sea, and we also show that in the film. And show the satellite not only watching the sea, but also what humans are doing to the sea. When the currents, these beautiful rivers, the oxygen of the sea bring pollution with them, but that's not all. It's not just the damage. We also show the beauty, the salinity, the movement of the currents. To watch all that from the sky is like being in a heavenly balcony along with the gods, watching the theatre of this beautiful planet.
You might think it's only salt, but this humble mineral is a key factor, together with temperature, in the circulation of the sea, which in turn has a major impact on our climate.
We know a lot about the sea nowadays, and our knowledge of salinity is perhaps the final piece of the jigsaw when it comes to creating an accurate and reliable model of oceanic circulation.
Jacques Perrin is a geophysicist here in the southern French city of Toulouse. For 25 years, he's researched the water cycle of our planet in order, for example, to improve agriculture. New data should be provided by the SMOS satellite, the Soil, Moisture and Ocean Salinity Project, the second of ESA's Earth Explorer missions.
The special thing about this satellite is that it covers two research areas that have not previously been explored. It'll start by collecting data from the surface of the ocean about salinity and from the land surface about soil moisture. This data has never been collected from space, and complete data has never been collected at all.
The satellite captures the microwave radiation of the Earth's surface. The advantage of microwave systems is that they work day and night, even when there are clouds. To get the best resolution, SMOS uses 69 interreactive antennae mounted on the satellite's three arms. This truly new approach in space results from international cooperation, most notably between Spain and France. Jacques Perrin could even be seen as the father of the SMOS satellite. His team at the Biosphere Study Centre is testing the algorithms for retrieving the useful information from the data.
We can't prevent the data being contaminated by snowfall, thick vegetation, etc. But what we can do is build enough confidence in our model so that we can say, up to this thickness of snow or that amount of vegetation, we can trust the SMOS data on soil moisture.
The first 6 months of the project will be spent validating data. Soil moisture is measured on 5 so-called anchor sites, giving a relatively precise picture. At sea, surface salinity and temperature are measured by thermosalinographs, either floating freely or on board ships.
Commercial vessels have started carrying thermosalinographs on board, so commercial routes are quite well covered. But the rest of the sea is covered by about 3,000 buoys right now. And what are 3,000 buoys in the context of the world seas? There are lots of gaps in the data.
SMOS aims to fill these massive gaps. Thanks to the satellite, it will be possible to draw up a global ocean salinity map for the first time. And with this, researchers hope to get a more comprehensive understanding of the ocean's circulation. This could help to explain extreme climate phenomena like El Niño, or why, for example, hurricanes gain strength when passing over the warm and less salty mouth of the Amazon River. And there is also the Gulf Stream to investigate.
The
main impact that people will notice is better weather forecasting. We think we'll be a day earlier with forecasts of extreme events, torrential rain, floods, droughts. And the project will help people manage water resources and reservoirs. And at sea, obviously, we'll have better knowledge of the ocean's currents, the movement of warm and cold water masses.
From its orbit 760 kilometers above the Earth, the SMOS satellite will complete one global coverage every 3 days. Researchers worldwide will have access to its data.
SMOS just measures. It can't provide a solution. I often tell people, look, it's like a thermometer. It'll tell us the patient's temperature, but it can't heal them. It simply tells us how ill the patient is.
And the sea is ailing, caused not always but often by human beings. So knowing more about the sea could contribute to protecting it.
Right now there's almost an island of rubbish forming in the middle of the Pacific. Fish stocks are decreasing, pollution shows that the sea suffers from mankind's actions. And because the sea is a reservoir that stores things long term, we risk paying a high price later on.
For Jacques Perrin, an appeal on behalf of the sea is part of his movie. It's a silent one, however. He prefers neither to explain nor to advise. He prefers to raise awareness by seducing his audience with stunning pictures and the beauty of the oceans.
When you see the exuberance, the diversity, the incredible beauty of all these animals, it's magnificent. A hymn to the marvels of nature, and all that is extremely fragile. What we need now is for decisions to be taken. What we need now is a protection force for the sea, so that everyone understands that treating the sea this way isn't even logical, it's not good sense. Everyone has to understand that.
The impact of mankind on the sea is widely recognized today, but the influence of the oceans on our climate is sometimes less well known. We still need to study the sea.